So my name's Grant Corse from SeaScope Fisheries Research. We were involved in the previous EFF funded project, which was looking at evidence gathering from the Scottish fisheries, basically to improve stock assessment collection, data collection, due to very sort of constraints based on remoteness and accessibility of getting this data. So we looked at sort of the using electronic monitoring equipment on that project. So if I just okay, so Richard Ayres was supposed to give the presentation. He's actually, as I said, he's not available, but his background is he's been working in electronic monitoring and fisheries research for about 30 years. He was one of the chief developers of the CFAS electronic data capture system, which is being used on the, I think, Marine Scotland RVs as well. And it turns out he's also been working as a fisherman on a potter from Bridlington and on the Channel Coast as well. So he's very experienced, over 30 years. So SeaScope we've been subcontracted to the CFIS project. We're involved in, again, work packages, but we're involved in 4 work packages or sub-projects, which are called 2A, 2B, 6 and 8. For this presentation, we're just going to really concentrate on 2A and 2B. Work package 6 is to develop the database, which is going to feed in the information collected from the 2A, 2B work packages, which are looking at developing electronic monitoring equipment to automatically collect data for stock assessments. And work package 8A is just, which Tanya I think is going to talk about later, is actually just supplying observers to carry out onboard surveys and work with the fishermen. So as Mark said earlier, this is it's a pilot project. We don't expect to have a system that can roll out onto every single vessel at the end of this, but we're hoping that while we're developing these solutions, this 2A solution, which is going to try and gather information on spatial and temporal information based on where the boat is, what he's doing at sea, and how we can sort of interpret the data collected from GPS without impacting on his workload or destroying lots of expensive equipment at sea. So what we have to design is something that's ruggedized and able to collect the data in a way that doesn't impact on normal working activity. And of course that's going to require an awful lot of input from the fishermen and a lot of help to make sure we get it right. So the benefits from improving the data would obviously be that, I mean, up until now it's been very hard to get stock assessment data from shellfish fisheries on the west coast of Scotland, for instance, simply because of the remoteness. It's expensive to send people across to get samples from 2 or 3 boats on a trip, and if the weather's bad and you get stuck for a week, it becomes very expensive. So if we can automate that process, you can improve the data, which then improve the science, and then it'll actually improve the advice and management, and hopefully secure a better sustainable fishery. And sort of the benefits to the fisherman here is that if we can actually automate the data collection, then he doesn't have to fill in lots of forms and make sure they get submitted on time. The data can be hopefully almost real-time sent to whoever needs it through mobile phones or Wi-Fi connection. And that'll allow us to have an awful lot of good spatial data which can, and sort of real time, which can hopefully lead into management solutions which can be done sort of on a localized basis. I can't say that will happen, but I mean obviously that would be eventually hopefully one of the things that occurs. And a sort of side issue we thought was something that would be beneficial to fishermen would be the actual traceability, to be able to show your customers where something's caught and actually have full transparency on a fishery. So the other side of this was the data you're getting on spatial data will also allow you to have an evidence base that you can take to marine planners or stock managers or anyone else who might impact on your fishery grounds and say, well, look, this is where we fish, here's the evidence to back that up. If you link that to our catches, you can see that what we're telling you is right. So there's a benefit there to the fishermen, hopefully, and also to the marine planners and to everybody to allow a fuller picture. And there is the potential that the data could then also be used by various users, including the fishermen, and they could look at their own sort of data analysis and hopefully look at it in a way that actually maximises their returns. So what are we collecting? So work package 2A, sorry to use the numbers and the work package words again. Basically, if you think of it as like a sort of small control box, it's going to be in the wheelhouse, and it's going to link to GPS and have time-stamped positional data. It's not going to use any bought software, so all the software is going to hopefully be free. It's going to be open source software. The hardware is going to be cheap, and it's going to be something that can go on small boats without impacting on space in the wheelhouse. The data, the GPS data we're going to collect is at one per second, and that allows us to get very good precision on where someone is and what they're doing at a certain time. And this is all about collecting scientific positional data, which we can hopefully then link to other information such as catches. And the control box will also allow all the other work packages to link to it, so that the actual information can be downloaded onto that, and then from there can be communicated to a central database, which is the work package 6 database. And again, hopefully without anyone having to do anything. So as I said, it's designed for small vessels, and it's scientific data collection, multiple sensor inputs, and near real-time data. We'll be requiring we would like to have 15 vessels try the systems out once we've developed a prototype, and that's something we can talk about a bit later. So work package 2B, now this is one of the pieces of equipment that we're hopefully going to feed into the control box, and this is going to be, we've been calling it a chute, but it might be something completely different, but basically it's technology that's going to allow us to collect species ID, counts on the species, sex ID, and also length measurements for every crab and lobster that's caught on board the vessel automatically. We've been looking at quite a lot of different types of technology. So for the effort information, for instance, it's good to have that catch data, but you have to link that to effort. So to get the effort data, we're going to have RFID tags and mechanical switches to make sure we can get a count on pots and strings deployed. And because that's going to link to the GPS in the work package 2A, you'll have all the string and pot data linked to position, and then you can then calculate things like soak time. And then the catch data we collect will hopefully then allow you to have a catch per unit effort sort of calculation based on that as well. And because we're going to try and capture the discard elements as well, you're going to have discard data and retained data all feeding into that for hopefully at a string level. It says we have no ideas how to achieve this, but we've got some. So we've started looking. In fact, we've actually just finished writing the feasibility report, which we've submitted the draft today, and that's going to allow decision makers to decide what the next step should be on that. So we've looked at an awful lot of different types of technology, including near-infrared spectroscopy, 2D scanning, 3D scanning, thermal imagery, computer vision, video learning. So yeah, computer learning. So the kit, as we said, it's going to basically, because we have to build in a bit of redundancy, it's going to be small, low-powered with 2 GPS loggers. We're going to have a standalone data storage, and we're going to hopefully be able to try and communicate this through the 3G, 4G networks, or if there's the possibility to do it via Wi-Fi in a port, then we'll try and do that. Now obviously we're aware that only 1 or 2 ports will have Wi-Fi capability, but it's something we can look at and see how much it even costs to perhaps even install that specifically for a small port to do the trial. So these are the pictures of the kits. We've got the communication device at the top left. On the right there, top right, that's just Raspberry Pi, which we're going to basically build it around the Raspberry Pi system to allow lots of different kit to feed into it, and very cheap. We've got the GPS loggers, and then you've got the standalone data storage. Like I said, we need to have 15 vessels involved to do the 2A, and 5 vessels involved to do 2B, which is the control box and then the onboard chute. But what we need to sort of start communicating with industry through the facilitators to try and make sure we're getting the right information. So we'll talk to the facilitators, and then they'll hopefully talk to industry and get some ideas back on that as well. So one of the questions we just said is, what are the easy ways to sex crabs and lobsters? And that was just simply on 2B, because if we're looking at video technology to identify them, scientists do it one way and fishermen do it a completely different way. So scientists, you look at the abdomen and go, right, so there's a male crab there on the left, and then on the right you've got the female crab based on the size and shape of the abdomen. But if you look at the bottom picture there, those two crabs, I mean, the one on the left is a male and the one on the female on the right is a female, and they have a completely different shaped carapace. So by looking at our 2D scans, we've actually seen that we can actually identify sex just through a shape scan almost. So, but there might be other things we don't know about. So maybe fishermen are more aware of other features which they can tell us about, and perhaps we'll maybe do a small morphological study to try and work out some other parameters, because there's not much literature out there. So what happens next? 15 vessels. As I say, we need to recruit 15 vessels to trial out the 2A control box, the logging equipment basically in the wheelhouse, and the 2B system that's being assessed. The proposal is being assessed now by St Andrews and Marine Scotland, and hopefully we'll start with field trials in spring 2018. And that's who we are. Thank you.